So these are the 9 features that we'll be talking about in this video. An important thing to notice is that your architecture may be developing step by step. So I'll start off with something and then we'll see how it evolves. In case you find something not, let's say, discussed in as much detail as you like, you can always post that in the comments below and we can have a discussion over there. Alright, so initially we just have 2 users. One is a mobile and another is a desktop. Let's say the mobile is connected using the app and the desktop is connected using their browser. So how do you actually make these guys connect to your system? The very first thing that you're looking for is some sort of a external guard, a gateway, a person who makes sure that whoever is connecting to your system has a known place to connect to. So this is called a proxy server in some places, but I call it a gateway. What this does is it routes requests to the right places. That's one responsibility it has. So the gateway has the responsibility of routing external requests to the right places. For that, it needs to have some sort of mapping that if I send a register request, where do I actually send the register request internally? There are multiple services inside. Let us say one is a profile service, one is a session service, and so on and so forth. So there's multiple services. There needs to be a mechanism for this gateway to be able to identify that every register request has to go to service number X. Let's say gmail.com/auth comes in. Okay, it will have some parameters like username equal to Gaurav and password will be super secure. So I'll set it as XYZ. So the thing here is when you hit this URL, what's happening is gmail.com means this request is routed to this gateway. After that, the method you're trying to call is called auth. And we need to be able to tell that if the method auth is called, that routes to the auth service. So there are 2 routing mechanisms at work here. The first one, as you can see, is Gmail to the gateway. Now this is going to be handled by the domain name servers that are out there on the internet backbone. As you have an internet service provider, usually they contain the DNS with them. The DNS is like a registry. It tells you that this domain maps to this IP address. And you can check that out in case you purchase a domain, you're actually purchasing a place in the internet which can be connected to from the outside. So when we said gmail.com, we actually hit an IP address of the gateway. Internally though, we have to do the same thing for our auth service. Let's see if we can pick up some ideas from the public internet for our own service registry. What happens is whenever the auth service is turned on, when the service is switched on, it will register itself to the gateway stating that, hey, I'm the auth service. If anyone hits this URL, auth, please route it to me. So the gateway needs to have a table stating that what is the method name that is being called and which service does it route to. In case auth is called, the service that will be routed to is authentication service. Similarly, if someone says update profile, that routes to the profile service, okay, and so on and so forth. The other thing is if someone is trying to attack your services, someone is trying to flood your service with a huge number of requests, this gateway service will be blocking those IP addresses. It blacklists IP addresses. So that's actually the second job it does. Blacklist IPs. It can keep some sort of a rate limiter inside, noting down the IP addresses which are sending requests. If you exceed a particular threshold, so we have a rate limiting video in the same series, but if you exceed a particular threshold, I'm going to note that down and I'm going to block all subsequent requests from you for a particular number of seconds. You can also permanently block users, permanently block IPs, which are very suspicious. Translates requests. Taking these HTTP requests. HTTP is something that the entire world understands, so everyone sends you requests in HTTP. It's like a language like English, okay? It's useful, but maybe you want a far more efficient language to talk to for your internal services. So you might have some protocol written over TCP internally. I just want to get into this a little more. HTTP is a stateless protocol. It's a client server protocol. You may or may not want that kind of stuff inside once you have the internal services all talking to each other, because HTTP also has kind of large headers. If you want to make your internal service calls more efficient, it might be worth investing your time to use some protocol built on top of TCP that you can use for your internal service communication. Do you see some problem here? Yeah. What's happening is this gateway has a lot of responsibility. So there's a lot of jobs it's doing already, and now you're asking it to do even more by noting down which service maps to which method name that is being called. So instead, I'm going to decouple this, and I'm going to take the method name and service information, this information, that who is responsible for what API being called, and push that into the service manager. So when the authentication service comes up, it has to register itself to this service saying that, hey, these are the method names that I handle. Now when someone calls gmail.com/auth, what you do is in the gateway, you ask the service manager that, hey, where does auth map to? Give me the service name which is handling this API call. And the service manager will tell you that auth service handles this call. So I'm going to be forwarding this request with the username and password to the auth service. And with this request body, I'll get some sort of a response from it. So the auth service needs to have some sort of way to be able to register me in this system. So in this database, it should have a user ID, which is the username itself. The password, hopefully in the database, is encrypted. We need to have some sort of phone number. This number should get an SMS from the auth service saying that, are you really this user? So the only way for me to verify this is to send you a secret code. Now I can stuff information in this very table, but instead I'm going to keep a separate table, which is going to say, this user ID got a code of 123 with a particular timestamp. So it has an expiry also. So maybe this code expires per day, and you can look at the latest code when your user tries to authenticate themselves with a two-factor verification, right? And the user ID here is Gaurav. The user ID here is also Gaurav. How do you send this SMS to a person? So for that, I need a separate service called an SMS service. The SMS service will be sending SMSs based on what your requirement is. So if you need to authenticate users, it has a template of, hey user, this is your verification code, which is 123. Please type this into the browser to log in. Sometimes you might need to send an SMS alerting people that, oh no, there's a suspicious login into your account. So for that, you'll have a separate template, an SMS template. So what happens in the SMS template, it's very similar to any template you can think about, resume templates, is that you have the text already set here, and there are some blanks that you have to fill. So the username is over here, like 2XYZ, your user verification code, which is in this case 123. Please click on this link to verify. So the link address might also change. The SMS service basically has a set of templates based on the kind of message it is sending. And the request parameters actually tell you how to fill that template. So the request parameters in this case will be code is 123, user ID is Gaurav, so on and so forth. And the database tells you the things to send. An important thing to notice right now is that I'm not going into too much depth in any of these services. The main reason being that even in an interview, you don't want to be focusing on one service to a tremendous amount while ignoring everything else. That may not be something that your interviewer is looking for. Another thing is that you don't get the proper breadth of all the systems, internal systems that are working inside this. Because you have mentioned 9 features. If you can finish 4 to 5 features at least, that makes sense. In fact, the best thing would be that you negotiate with your interviewer saying that these are the 4 features that I want to talk about in this, and if I get time, then I'll pick up other features. The authentication service is kind of done. What it has done is it has taken down the user ID, the password, set the phone number, and sent you a response saying, okay. This okay is telling you that please verify yourself using a two-factor authentication. So the gateway sends this forward to the user saying, okay, but you go to the next step. Basically, the page changes and you go to the place where you have to send this code of 123 now to complete registration. So I'll be adding another field in this profile, which is verified. Initially, this field is false. If you're not verified, you're not a user of the system. You're just a person hanging in limbo. Till you verify yourself using a code, I won't accept this. What else can happen? Let's say a user never verifies themselves. This stays false. Let's say a user comes in with the same email ID, asking for the same user ID with a different password and says the phone number is something else. This depends on what kind of user experience you want to provide. But if a person is using the same user ID, you can stop them. You can tell them no. Okay? Because you made the mistake of sending the wrong phone number, or you made the mistake of not verifying yourself. So it's not my fault. You use a different name now. So with a different name, with a different user ID, this is the primary key. You can create a separate account and then verify yourself. So the user goes to the next page. They say that the code is 123. The gateway again says that this is an API call to gmail.com/verify with the username and the code over here. So of course the auth service has already registered itself to handle this verify method. The verify method contains the code and the username, which are sent to the auth service. The auth service says that, hey, the code was 123, right? With the particular timestamp. Is it within the time allocated for this code to be verified? Yes. Is the code correct? Yes. Good, job done. So say verified. So that is the second response. And once that is sent to the user, this user is now a verified user. Internally, the auth service will set this to true. And now you are a registered user of the system. You're now a registered user. Would you like to add your details so that it's easier for people to recognize you, blah, blah. So that is gmail.com/create profile. And because this is a complex thing, I'm going to be considering this to be a post request, right? A GET request is where you can put your parameters in the URL itself. A post request has a JSON object, and I'm expecting this to be a profile object, which is going to be sent to the gateway again, of course. And the person who's registering for this is the profile service. Profile service says that, service manager, I want to take all create profile API calls and handle them. When you say you have registered for it, actually what you're doing is, I am the profile service. I have these IP addresses. I run on these boxes, right? The profile service is a distributed service. So it runs on 3 boxes with IP address. All requests of this type have to be sent to me, and I exist on these 3 boxes. The other thing is, if one of these boxes crashes, there needs to be some sort of a heartbeat mechanism by which we can identify that a box has crashed. You can check out one of the videos on YouTube that I made on this. It's called the Service Discovery and Heartbeats, which talks about this in more detail. But the important thing is that there's a constant communication between the service manager and all other services, which tell it that, hey, I'm alive, hey, no response coming for a long time, so you're probably dead. So the service manager manages the entire state of the system internally, and it's able to give this information to the gateway whenever it asks it. Important thing here, the gateway is asking the service manager, where should I route this request every time? So is the gateway manager actually, is the gateway actually routing requests? No, it's not, because all it's doing is it's asking the service manager, where should I route it, and then sending the request. If that's the case, then it can just tell the service manager, you route the request. Yeah. But we don't want to do that. We don't want to make this unnecessary API call every time a request comes in, because it's not going to be that, the profile service used to handle create profiles today, and in 3 seconds, some new service is going to handle create profiles. So you can store that information once and keep it there for a while. So basically you can cache this information. This mapping, right, that you are storing here in Service Manager, you can take this mapping every hour and you can send it to the gateway, the entire mapping, which will be cached in the gateway. And so it doesn't need to make this call to a Service Manager and get the response. It can read up over here itself. This cache is going to be, so to speak, maintained by the Service Manager. Okay, so if the Service Manager says that the create profile is now going to be handled by somebody else, then you update the cache.